Much better, much better. I like my Mathline theme song, but you know, it's Christmas Day. I hear let it snow, let it snow, let it snow. Oh, I like that, I like that. A little bit of mood music. For those of you who are watching us today, we thank you for making us a part of your Christmas Day and your festivities and such. And those of you who aren't watching, hey, we'll be around next week, okay? So you can see us then. Of course, you're not going to hear this anyway, are you? But anyway, we have the Let It Snow, Let It Snow, Let It Snow. Thank you for tuning in today. This is Mathline, TNLearn's Mathline. I'm Ernie Roberts. I'm your host on this Christmas Day. And you know what? We're going to carry on like we carry on normally. Let us see our opening slate here, all right? The first day of Christmas. Wow. You know, there's 12 days of Christmas. You think, am I going to sing all 12 verses? No, but we're going to talk about them. We're going to talk about them here. But let's take a look first before we got to get started working together. Let's see what we're going to do with this first day of Christmas. It says, my true love gave to me, you know the song, a partridge in a pear tree. How many gifts were received each day? Now, before we do that, we got to get a little festive here. I'm in red today, all right? And let's hang, oh yes, a stocking. Where can we hang a stocking in here, guys? Where can we hang it? On the Elmo, yeah, here we go. And we'll stretch it out there. All right, Santa, if you didn't get by last night, I'll look for you tonight, all right? But we are ready to go with Mathline Christmas today. Glad to have you with us here. And the question bears looking at, how many gifts were received each day? You say, well, Ernie, that's easy. It was 1, 2, 3, 4, 5. You know, we're going to talk math, aren't we, even on Christmas Day? So let's see. Oops, we got to keep Elmo and the stocking happy. There we go. All right, and let's see what the story is on this. So if we can go back to seeing what happens from there. Oh, we've got more days, don't we? And you know the song goes, on the second day of Christmas, my true love gave to me 2 turtle doves and that means plus, folks, we're going to add. So a partridge in a pear tree. So on the second day, you didn't just get the 2 turtle doves, you got 2 plus 1. And that gives us 3 gifts. So the first day you got 1 gift, you got the partridge in a pear tree. The next day you've got 2 turtle doves and another partridge in a pear tree, plus the one you had. So goodness sakes, you're up to 4 total if you were going to look at that. But right now we're just going to see how many do you get per day. How many gifts are you getting each day? So on the second day, you got 3 gifts, all right? The next one, we get these 3. So we get 1 partridge, 2 turtle doves. Not going to multiply them, we're going to add them. And we're going to add 3 to that. It's enough things going on once the French hens get involved here. And we get 6 totals there. Oh my goodness, this house is getting full because we had 1 plus 3 plus 6. We're up to 10 animals. All right, so let's see. 4 calling birds. It's getting worse. We're going to take those 6 that you get, the 3 French hens, the 2 turtle doves, and the partridge in a pear tree. And we're going to add the 4 calling birds. So it looks like we're up to 1 plus 2 plus 3 plus 4. We're up to 10 gifts in one day, plus the ones you had before that. The house is getting full, folks. Put them out in the yard. Put them out in the yard. It sounds like a good thing. Some nice things, 5 gold rings. Sometimes they call them 5 golden rings. And the 5 gold rings are going to be basically added to our 10. I'm not going to write 1, 2, 3, 4 again. I think you get the idea what's going on here. And we're going to add 5 to that. And we now have 15 gifts. 15 gifts. Gold rings could be worth something. I'm not sure about all these crazy birds and things that are flying around and laying eggs and other good things around on you. But what I want you to notice here is this little thing, a little mathematical moment, all right? You know me, I like to bring math in wherever I can, even on the 12 days of Christmas, on Christmas Day. Here we go. These are what we call triangular numbers. And I'm going to show you because there's the partridge, and there are our 2 turtle doves right there. They look alike, I know. But they make a triangle. 3 is a triangular number because we can put those points into a triangular region, all right? The same thing here. We can continue to create this triangle. There's our 2, and now let's add 3. And you see how nice that is? It's another triangular number. So there's 3, there's 6. If I want to go ahead and run the pattern again, and I'm going to, everybody goes bowling once in a while. Go bowling tonight. That'll make you mathematical. Keep score and all sorts of other good things. But you know, when you put this triangular number 10 out, those of you who go bowling know what I'm talking about. That's a setup of how your pins are before you're going to be able to strike. Hopefully you roll strike, or you're going to at least roll the ball down there and get some pins knocked down, all right? And we could continue on with this to make another triangular number. You get the idea. Almost looks like Christmas trees developing here. See what I can do? I can put a little bottom there. Oh, happy campers we all are. All right, but anyway, that's a nice thing about the triangular. Oh, I can't resist this. It's Christmas Day, folks. There we go. Christmas trees, we can do that all the way around. But they're all triangular numbers, and they keep adding on to this crazy insanity, all right, of the 12 days of Christmas. So let's see what happens once we get rocking and rolling here. My goodness sakes alive, we got now 6 geese a laying on the 6th day. So we ended up with 15 gifts. And we're going to add 6 to that. So we are up to 21 now. And then we're going to take that 21 for the 7 swans a swimming. We're going to put 21 plus our 7, and we're going to get 28. Now, what I want to point out to you is we're getting a nice thing called a sequence. Those of you who have been in Algebra 1, Algebra 2, and those of you who have been anywhere around the world, even now in the middle school and the elementary school, we're looking at sequences. So here's what happened. We started with 1, 3, we jumped up to 6, we hit 10, 15, 21, 28. Now, the game plan here is, notice what's happening. First of all, we increased by 2, going from 1 to 3. See the difference? We look at the next one. There's not a common difference on this, so it's not like an arithmetic or arithmetic sequence. It's just a sequence of some kind of crazy numbers, which looks like a little bit nonlinear to me. And we've got a difference of 3, then a difference of 4, difference of 5, you get the idea, difference of 6, and a difference of 7. So our second differences do come out to be constant up there. We're increasing each time by 1, but in this respect, they're increasing by a different number each time down here in the first set of differences, our first line. So I bet you can guess what's going to happen with the 8 maids a milking. That's our next one. We're going to probably add 8 to this, and we're going to pick up 36. Let's go to it and see what's going on with the 12 days of Christmas. Here we go. 8 maids a milking. That's the next one here. So we're going to pick up our 15 that we had originally, like I said, and add the 6. So that's going to give us 21 gifts we get on the 8th day. Things are getting a little out of control here, I think. Someone needs to, get off this gift-giving kick here just a little bit. We've got now, goodness sakes, we have gotten to the 21. Nope, that was on our maids a milking. We want to go, that was our geese a laying. This is our swans a swimming. Let's go back to where we were, which was 21 plus 7 equals 28. Now we're ready to go to the maids a milking. All right, we're going to take 28 plus 8, and that's going to give us 36 as we continue our sequence on. So we picked up from where we were, and notice each time we went up by 6, we went up by 7, then we got up to 8 extra, so 36 on the 8th day gifts. Very, very expensive date here, it looks like. And we've got 36. We're going to add 9 to that. We get 45 on the 9th day. Keep going. How about it? 45 plus 10 on the 10th day. 55 gifts going in. And now we got people running all over the place. So the house is going to be packed. The house is going to be packed. Let's finish it up with 55. We'll add 11 more, equaling to, whoa, how about that? 66. And finish it out, 66 plus that 12th day, you are at 78. Big numbers there. Put them all together, add all these together. You know how many gifts you received over those 12 days, counting the repeats, and there were a lot of repeats, a lot of partridges in a pear tree running loose there, 12 of them. 364. 364. That's like one a day, except one day for Christmas Eve, and then you start all over on the first day of Christmas once again. Get a little rest one day from all those crazy gifts and stuff. But anyway, great thought there. And that is the way numbers work. They are always fascinating. What do they actually do when they get together? I bet no one has sat down. I'm sure someone has sat down and figured out how many gifts they received. But 364, like one gift a day for a whole entire year. As we said, inquiring minds want to know how many gifts were given for the 12 days of Christmas. I counted up 364 total. That's a lot. That's a lot. All right. So in worth of our numbers here, today is a little bit unique because it is Christmas. And I love the 12 Days of Christmas song. And I want to go to a little point here. It says the last 4 verses have had many orderings. In other words, people sing them all different ways. Usually days 1 through 8 are all the same way sung, all right? But the 9th, 10th, and 11th, sometimes they think, oh, is it 7? Is it 9 pipers piping? Or, oh, maybe it's 9 lords leaping. They get those a little confused around, all right? So, and it's okay. It's legit. But it says, how many ways can you order these gifts? So you're going to take 4 items, 4 gifts, and you're going to order them 4 at a time. It's a permutation. That's an Algebra 1 term, okay? Back there to Algebra 1. Actually, some of you people in 7th and 8th grade are getting them also. Some of you kids out there know what I'm talking about. Hopefully, all of you that are above that age have a clue what I'm talking about. But anyway, we write it sometimes for a notation. We write it 4P4 because that's a permutation 4 at a time, all right? And when we do that, the formula is really very simple. It is going to be 4 factorial. You say, well, what's that? It's time for a math lesson, isn't it? Here on Christmas Day. That simply means 4 times 3 times 2 times 1. In other words, we start the number here and we multiply down till we have none left, all right? And what that would do, that would say, okay, maybe I start with lords a-leaping, go to the ladies, go to the drummers, end up with the pipers, all sorts of different ways we could do it, all right? 4 options times 3. Once we pick the first 4, we got 3 options left. Then once we get those 2 set in stone, we've only got 2 options left. And once we got all that, there's only one way the last one can force its way. So that's how we know, which, by the way, I guess we want to know what it equals. It equals to 24 possibilities, 24 orderings, okay? So 24 ways you can sing that song as long as you sing the first 8 verses correctly and in order, all right? So Merry Christmas, folks. We've got some great times with the 12 days of Christmas. So another good thing about today's show, we don't talk about how many shows we've done, but Christmas time we sit back and we reflect a little bit. This is the 100th show of our new season, which started back in August. Many of you have been with us from day 1 of that. We appreciate you. We appreciate you so much. But actually, we have a total since we have started Mathline of 360. Now, 360 is a great number in the world of mathematics. So let's take a look at this number and see how it's used. It's the 360th show, and in honor of this milestone, spread over 2 years now, we're going to find the set of all the factors of 360. I'm going to tell you something, folks. There are a lot of factors of 360, all right? That's why it's such an important number in geometry. It's the total degrees in a quadrilateral. That would include rectangles, parallelograms, squares, trapezoids, all those great things. It's also the number of degrees in a circle, 360. There's so many things that will divide into 360. That's why it's used for so many things in geometry. Also, if you look at the sum of the exterior angles, 1 per vertex, some of you are knowing what I'm talking about, others of you will get it when you get to a geometry class in high school, it's also 360 degrees. And there are other great little moments that use 360 to get us going on places. So don't take the lowness of this. It's a big show, all right? It's the 360th because it's got so many ways to divide things. And let's look at those ways, okay? How many of the factors we've got? Let's always start with the extremes. 1 in 360, all right? Keep kicking along here. 2 and 180. 2 times 180 works together, gets us 360. How about it? 3. 3 is divisible. Notice we got a 3 and a 6, so we know it's going to work. How about it? 3 times a 120, all right? Pick up a 4. The numbers are starting to come down over here, but they're going up on the left-hand side here. Pick up 4 times 90. 4 times 90. That'll give us 360. 5 has to because it's got a 0 on the end, so it's going to be divisible by 5. So we put 5 times our 72. There's another pair of factors. And 36, I always think of 6, don't you? Everybody out there always think of 6. So 6 times 60. Whew, we are still pretty far apart here, all right? We've already got 6 pairs. Let's see what else happens. Let's move another column over here. We're going to go to 7. No, we can't do 7. It's lucky 7, but we cannot do it here because 7 won't divide into 360 evenly. So let's go to 8. Let's pick up 8. 8 times your 45. How about it? 9 times a big old 40. Goodness, is every number? Nope, 7 didn't work, but almost every other number has worked. How about it? Let's take 10. Divide 10 into, 36. 36 times 10 will get it for you, okay? And can we go 11? No, but we can do 12. 12 and 30 work great together. 12 and 30 work great together as we multiply there. Getting closer. 13, nasty number, doesn't work well. 14, doesn't work here either. 15, oh yes, 15 times 24. 15 times 24, that looks good. And you know what? I think 18. I believe 18 is our next choice. 16 could be nice, but it doesn't function here, all right? 16 does not go into 360 evenly. May have, with the decimal, it may work, but we've got that. All right, so we're going to take 18 times 20. That's going to be our last set of factors. My goodness, folks, count them. 24 factors that will divide into 360 evenly. I don't think I left anyone out. If I did, y'all can tell me about it. 16 was one I was almost worried about, but 16 I think is working pretty well there. All right, 16 works very well, but not into 360. 16 is a nice number. You got a lot of factors, but sometimes they just don't always work together. All right, and this time they didn't work with 360. Now, again, another thing we do when we factor out, sometimes we talk about prime factorization. So let's take a quick shot on this. And that's where we pick up the factor tree. Factor tree. By the way, those of you who are just tuning in, this is Mathline, and it is a Christmas type day, but it's also our 360th show, so that's why we're talking about 360, all right, up here. Plus, it's a good geometry term, all right? But let's prime factor this thing out. And I'm going to go for 18 and 20. Why not? 18 and 20. Close together. They work pretty well. And let's start breaking things down. Breaking things down. Boy, lots of numbers here. We've got 18. That'll break down into, how about it, 3 times 6. And remember, we're looking for prime factorization, so we keep breaking down until we have no more numbers that we can break down off here. We can do the 6, by the way, down to 2 and 3, or 3 and 2, however you want to write it. And when we get to the primes, let's circle them, because there are a lot of numbers in this diagram. So I want to know what my final answer is going to be composed with. Here we go. Over here we got 4 and 5. 5 is a prime. 4 will break down to 2 and 2. So what we're going to do, prime factorization means we're going to take our primes, which in case we have a 2, and 2 is going to go to the third power. I count 3 of them. 2 times 2 times 2, that gives us the 8 part. I see 2 3s. Multiply that, 3 to the second. And last but not least, you got that lovely 5 right over there. And folks, there we have it, our prime factorization of 360. So again, happy 360th show. You know, that means in 8 weeks, folks, we'll be celebrating 400 episodes of Mathline. Thanks to you, we can do that. Thank you so much for tuning in today with us also. Let's do one more Christmas type moment here, all right? If the letters of Christmas Day are stirred in a bowl, now that's an interesting thought. We're not going to bake them or anything like that, all right? But they're stirred in a bowl. Let's put them on a piece of paper, fold them up nice, and we stir them up. And we're going to draw one letter at a time. Let's give the probability for each situation. And on first one, on the probability of drawing a vowel, we're not going to count the Y as a vowel this time, okay? We're going to go for A, E, I, O, and U. I was about to say oo, but it's U. And looking at Christmas Day, I see 1, 2, 3 vowels. You say, well, Ernie, so what? Well, now we want to know what's the probability. So that means what's our chance of drawing one of those vowels if we have all those letters of Christmas Day mixed up. So we have to know how many letters we've mixed up. Now, it doesn't matter if they're repeating. We've got every one of these gets its own little piece of paper. All right? So here we go. I count 3, 6, 9, 12. So there's 12 total. We are looking for 3 out of 12 here. There's our probability, 3 out of 12. That's going to pick us up with, reduce it, just reduce your fraction, 1/4 of a chance that we're going to get a vowel if we put Christmas Day scrambled all up in a bowl. Mix it up, stir it up. I'm getting hungry again, folks. Are y'all hungry? Y'all had enough to eat today? It's a great day to eat a lot of food. I know in so many places. Hope y'all had some good food out there, either tonight or already earlier today. Drawing the letter A. I see 2 A's. Do you see 2 A's? I see 2 A's. And I still have it out of my 12 possibilities, all right? Which is going to give me a 1 in 6 chance of drawing the letter A. So there we have it, 1 in 6. Now our consonant part here, on our consonant part, we're going to take that as drawing a consonant. We're going to let Y count. We're going to let Y count along the way here, okay? So this time, I count 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So we have 9 out of 12, which is going to give us, looks like, 3/4 if we reduce that. Now let's just do a quick moment here, because some of you are probably looking out there and says, now how did you go from 3/12 to 1/4? And sometimes I assume maybe too quick and too much, all right? But let's just see. What I did here, I took my 3/12 and I divided both these by 3, because 3 will go into each of these evenly, okay? It's a common factor. And that's where I pick up 1/4. 1/4. With the 2/12, I noticed that they are both even. So I know I can divide 2 into those. And I'll divide both of them by 2. Divide both by 2. That's going to give me 1 out of 6. All right. Last one. How about it? I start with 9/12, and I look at this thing, and I say 3 will divide into both of those evenly. So we divide by 3 on both sides there, and we get 3/4. So that's a simple thing. Folks, you know, I always talk about fractions. I always talk about knowing your times tables. That's how you do these things. When you reduce, you've got to work in reverse. You've got to think of a number, a greatest common factor here that goes in there. So even on Christmas, I'm telling you, know your fractions, know your times tables, know all those good things that are out there for you to deal with, okay? Now, when we look at Christmas Day, we've talked about so many different things here. We looked at those triangular numbers that make good Christmas trees. We talked about the 12 days of Christmas, how many gifts there were. You know, numbers come into so many things, so many ways, all these great things. And in fact, guess what? You all have been listening to how many shopping days there were before Christmas. Starting tomorrow will be another 365. No, not this time. It'll be 366 because it's leap year coming up. Do you know every 4th year we have leap year? And you know how you can tell if it's a leap year or not? I'm going to tell you. Some of you may wonder, how do you know that, Ernie? Well, let's look at the next year coming up. It's 2016, all right? And if you look at 2016, you're going to notice the last 2 digits. They are divisible by 4. They're divisible by 4. If that is divisible by 4, you get a leap year. And you say, well, how do I know it's divisible by 4? Because 4 will go into 16. Know your times tables. Exactly. 4 goes into 16 4 times, and that makes a leap year. Makes a leap year. So guess what? The next one should be 2020. Because once again, we've got a 20 on the end. So again, just a little bit of information that helps you get along the world through math and some of the fun things that we're going to have coming on. Now, the rest of this holiday season, for those of you who are still with me today, I hope you're here, we're going to be still doing some good, fresh new math. We're going to be continuing our series on factoring all through next week. We are fresh. We're going to be new. We want you to keep tuning in, and then we'll be live again come the first week of January. I believe it's January 4th, and we will be back live, answering your questions, working your math problems together. But over the holidays, we take a little bit of breather just like you do, but we still want you to stay fresh on your math because we've got a lot of good math still coming towards you. So speaking of good math coming for you, it is getting close to that time for me to have to sign off and say Merry Christmas. But let's look at this here. From Mathline to all our viewers, we wish you a Mathline Christmas and watch us next week. In fact, I mean this so much to you. I really do appreciate you guys. Appreciate my staff and my crew that put up with me and enjoy putting math together and are learning a lot of math too along the way, along with me sometimes. But let's sing this together. They're not going to sing on camera. They're saying thank goodness for that. But let's do this. We wish you a Mathline Christmas. We wish you a Mathline Christmas. We wish you a Mathline Christmas. And watch us next week. We wish you a Mathline Christmas. We wish you a Mathline Christmas. We wish you a Mathline Christmas. And watch us next week. You know, next week, we've got it. 5 days coming at you. And you know what? In 1 minute's time, how can I tell you everything? We appreciate so much the 360 shows we've had, a great holiday season for so many of you and for all of us, from all of us to all of you. We thank you for your watching, your tuning in daily. We also thank you for the Facebooking that you do. We always want to emphasize, like us on Facebook. All right, check us out. Our problems of the day will be posted there. By the way, problems of the day will come back also on January the 4th. Had Linda Garth, who told me from Middle Tennessee, said, I look forward to opening up Facebook just to see problem of the day. Linda, we appreciate you for that. Thank you. Others, James LeConte, who comments so many times on Facebook. There's lots of ways you can talk to us through Facebook. We have email going on. And of course, our favorite thing is when you call us live when we come back on January the 4th. We look forward to hearing from you. And folks, Mathline Christmas, and have a Happy New Year, and we will see you next week. Thanks for tuning in today.